Martin and I are doing problem number 4 in the practice problems for Module 11. Martin?
As you can tell from the gorgeous handwriting, it was obviously me that wrote that on the board.
Okay, so NaBr aqueous plus AgNO3 aqueous yields AgBr solid plus NaNO3. So, sodium bromide, what's Ag?
So, that's silver.
So silver nitrate,
Yes,
okay? So you're going to end up with silver bromide and sodium nitrate. What does it say in problem 4?
If a chemist needs to produce 100.0 grams of silver bromide.
Wait a minute, 100.0 grams of silver bromide.
How many liters of 2.5 molarity silver nitrate must be added to an excess of
Wait a minute. How many liters of 2.5 molarity silver nitrate
must be added to an excess of sodium bromide?
Okay. So we want to know how many liters of this. What is the equation for molarity?
Number of moles over number of liters.
So we'll be able to use our smarts to figure out this. Now, we have 100.0 grams of this. Okay. If I have 1 mole of this, how many moles will I have of this? I have 1 mole of silver bromide. How many moles of silver nitrate? That's correct. In this reaction, 1 mole of silver nitrate will produce 1 mole of silver bromide, right? So it's a 1-to-1 relationship. So what do we need to do? We need to figure out how many moles is 100.0 grams of silver bromide. Once we do that, we'll know how many moles of silver nitrate. Once we do that, we can figure out the number of liters at this molarity, right?
Right.
So the first thing we're going to do, this is unusual for us. We usually figure out things on this side and then apply them to that side. But this time we're figuring out how many moles we have on the right side of the equation first. So let's do so. AgBr, what is the molecular weight of Ag? So Martin is now looking at the periodic table at the front of the book, and he will tell me the molecular weight of silver.
107.9.
Heavy, man. 107.9. Okay, and Br?
79.9.
Let's make sure I do the math correctly this time. Now my decimal, 9 plus 9 is 18. Turn to 1. 7 plus 9 is 16 plus 1 is 17. I get 187.8. Do you get the same?
Yeah.
So that's 187.8 grams per mole, or 1 mole per 187.8 grams.
We do want moles.
So we want to find out how many moles we have. So we're going to multiply it by 1 mole per 187.8 grams. Grams will cancel, end up with moles. So in a moment, Martin, we'll use the calculator to divide 100.0 by 187.8, and he will give us to 4 significant digits the answer.
107.8 is 0.5325
moles. Are you sure about that? So you divided 100.0 by 187.8. Excellent. So 0.5325 moles. So now we know how many moles of AgNO3 we've used. How many, Martin?
0.5325.
Exactly. Okay. So since we know the molarity and we know the number of moles, we can figure out the number of liters. Let's just solve this. Molarity equals number of moles to number of liters for liters. First, I'm going to multiply both sides by number of liters. And I'm going to divide both sides by molarity. So number of liters is equal to number of moles per molarity, right? The number of moles, 0.5325 per molarity, which we're told is 2.5. Okay, so we'll get our answer in terms of liters.
It's going to be a pretty small number.
Are you sure?
5 divided by 5. 0.213. Yeah, it's pretty small. 0.21 liters.
Yes, we can have two significant digits. 21 liters. Okay. So the answer to number 4 is 0.21 liters of AgNO3. Okay, and that's it for problem number 4.